Welcome back to Math 104. At a blood drive, each donor has a 0.07 probability of having type O negative blood. We suppose that the blood drive will continue until a type O negative donor is found. That means it will stop as soon as the first type O negative donor is found. But if a type O negative donor has not appeared by the 6th person to be tested, the blood center will give up and cancel the blood drive for the rest of the day. What is the expected number of donors to be tested at this blood drive? As in the previous version of this question, we are asked for an expected number of donors, so we need to know what are the different possible numbers of donors that could result from performing this experiment. That could be anywhere from 1 through 6, and for each different possible number of donors, we need to multiply that number of donors by the probability that that's the number of donors to be needed. After computing each of those products, we will add them all up, thereby computing our weighted average of the numbers 1 through 6. By the same logic as in the previous version, the probability that we need only one donor is just 0.07. That's the probability that one person walks in and has O negative blood. For the drive to end after the second donor, that's the same computation as in the previous version, and similarly, for 3 donors, we need 2 with a different blood type, followed by 1 with the blood type we're looking for. 4 donors has a probability of 0.93 cubed times 0.07, so 3 donors we're not looking for times 1 donor we are looking for. 5 donors, now we can have 0.93 to the 4th times 0.07. That's what's different now about this problem from the previous version. The only way the blood drive can end after exactly 5 donors is if that 5th donor does indeed have O negative blood. But if the 5th donor does not have O negative blood, in other words, if the 5th donor and all previous donors do not have O negative blood, that is exactly what it takes to get up to donor number 6, and no matter what donor number 6 has in terms of blood type, that will be the end of the blood drive. So 0.93 to the 5 is the probability that the blood drive will end with donor number 6. We have to add all of these up, and when we do, we obtain approximately 5.043 donors. So that is the expected number of donors to be tested at this blood drive before it closes. In other words, this is the expected number of Bernoulli trials required for the first success. The number of trials is what is in question. The fact that we're looking for one success is fixed. A different blood drive on the other side of town has a different approach. They gather 6 donors and test all of them. What is the expected number of people with type O negative blood in a group of 6 donors, in the mathematical sense of expected? This is a fundamentally different kind of a question. We are not asking for the expected number of trials needed for the first success. The number of trials is not in question. There are definitely 6 trials. The question is, how many successes are there? So this is a job for the n times p shortcut. We are asking for the expected number of successes in a certain number of trials. Think of it this way, in order to use the n times p formula, there has to be a definite value of n. Here the definite value of n is 6. There are definitely 6 Bernoulli trials we're performing. There are definitely 6 donors we're testing. So those 6 donors times 0.07, the probability for any individual donor to have type O negative blood, and that equals 0.42 donors. On average, a group of 6 donors will have 0.42 donors with O negative blood. It is important to understand why this question and the previous one are fundamentally different and therefore have different methods of solution. Well, we've looked at enough different types of expected value problems for the time being. Please go on to the next video, which begins a new topic.